Hello, everyone. Welcome to section week 10. The daylight savings and yesterday on Saturday at 2 a.m. in the United States. I hope you were not looking for us for this meeting to start an hour earlier. This would have been 12 o'clock if we were in yesterday. So let's get started. We are going to review the problem set 6 today. The first question was, as a demographer, you are trying to understand how you can use a random sample of data to say something about a population. So we have the summary statistics of the population on the variable age in the data set. The question is, what is the population mean for age? As we see in here, in the summary, it is 2849. What is the population standard deviation, sigma, for age? It is 1956. Now, suppose you didn't have the entire population and you just took a random sample without replacement of 5 people from this population and obtain the following output. What is the sample mean for age? Notice that it is X bar. When it's sample mean, it is when it is population mean, it is mu. When it's sample mean, it is X bar. What is the sample age? Sample mean for age? It is 39.6, as you see. What is the sample standard deviation for age? It is 22.33. Why is the sample mean and sample standard deviation different from those in the population? Because our sample mean and sample standard deviation are based on the sample we took from the population. It is a subset of the population. It doesn't include the whole data in the population. It is expected that our samples, the statistics of our samples, are going to be different than that of population. If you took a second random sample of 10 people and looked at the same statistics, would we expect them to be the same as in the first sample? We wouldn't, because the second random sample of 10 people might be totally different 10 people, or some of them might overlap with the first sample. But it is different set of 10 people. So the sample mean and the sample standard deviation for the second random sample is expected to be different. Suppose you took many samples of 10 people from the population, each time calculating a different sample mean for age. What is the average of these sample means, approximately? Well, we know from the central limit theorem, regardless of what kind of distribution we have in the population, the sampling distribution is a mean of the population mean. So we can conclude that it is 28.49. Based on what you know about the population mean and population standard deviation for age, what is the mean of the sampling distribution based on a sample size of 50? The previous one was samples of 10. This one is sample of 50. Do you think it would be different? It wouldn't. It would be the same mean. Output on the variable age from 1915 Iowa census. Based on what you know about the population mean and population standard deviation for age, what is the mean of the sampling distribution based on a sample size of 50? Well, what is the population? Mean of the population, 2849, which is new. Mean of the sampling distribution, regardless of the sample size, is going to approximate the population mean. So since mu is 2849, the mean of the sampling distribution is going to be 2849. What is the standard deviation of the sampling distribution based on a sample size of 50? As we know, it is also called standard error. The sampling distribution, the standard deviation of the sampling distribution is also called standard error and is also called the standard error of the sample mean. And it is calculated by dividing the population standard deviation by the square root of the sample size. In this case, 1956 divided by square root of 50, which gives us 2.77. What is the mean of the sampling distribution based on a sample size of 100? And by now, you should say immediately that the mean of the sampling distribution, regardless of the size of the sample, should approximate the mean of the population, which is 2849. What is the standard deviation of the sampling distribution based on a sample size of 100? This is going to change because the standard deviation of the sampling distribution changes based on our sample size. So we need to calculate by dividing standard deviation of the population by the square root of the sample size. In this case, 1956 divided by square root of 100, which is 1.96. Based on what we know about the population mean and population standard deviation for age, what is the mean of the sampling distribution based on a sample size of 1,000? It is 2849 for the reasons we explained on the previous questions. Standard deviation, we have to recalculate because our sample size changed. 1956 divided by square root of the sample size, 1,000, and gives us 0.62. Does the center of the sampling distribution change as the sample size increases? As the sample size increases, the center of the sampling distribution remains the same. Remember central limit theorem and all the explanations in the lectures, and then all the examples we did before this question. Does the spread of the sampling distribution change as the sample size increases? Well, we have been calculating spread of the sampling, which is the standard deviation of the sampling distribution whenever the sample size changes. So we definitely know that spread is going to change, but in which way? Decrease or increase? As the sample size increases, the spread of the sampling distribution decreases, because when we have larger sample size, our spread is going to decrease. Our variability is going to decrease. We are going to have less variability with the larger sample sizes. As the sample size increases, would you expect a sample mean to lie closer or farther from the population mean on the sampling distribution? Well, standard deviation measures how far the data lie from the mean of the data. In this case, it is the mean of the sampling distribution. And we know the mean of the sampling distribution is population mean. So when the sample size increases, since we know the variability is going to decrease in the sampling distribution, and how can we answer this question? Would we expect the sample mean to lie closer or farther from the population mean, which is the mean of the sampling distribution? Closer, because as the sample size increases, the standard error of the sample mean decreases. Or because as the sample size increases, the standard deviation of the sampling distribution decreases. How many observational units are in the population? So in this case, we need to go and look at our R code. We run the library Mosaic. Our data we are going to work with has already been brought into R. And we are going to look at how many observational units. It's 55,003. How many variables? 5 variables. What is the mean of variable education? 6.97. What is the standard deviation of the education, variable education? It is 3.98. Take a random sample without replacement of 10 people from the population and calculate the average years of education. Now take another random sample without replacement of 10 people from the population and calculate the average years of education. Why do the two sample means tend to differ from sample to sample? Let's see if this is the case, first of all. Look at our first sample. And look at the mean, 4.3. Take another sample. Look at the mean, 8.35. So for the first sample, we had 4.3. For the second sample, 8.35. So it jumps around. Let's see what is the question is asking again. Why do the two sample means tend to differ from sample to sample? Well, the quick answer is those are two different samples. They are the different subsets of the population. They differ due to sampling variability. That is, through the process of randomly selecting people from the population, we expect the sample statistics to vary across samples. Take 500 random samples of size 10 and create a histogram of these 500 sample means. What is the shape of the distribution? What is the standard deviation of the distribution? This is the 500 samples of size 10. Mean of the sampling distribution is 7.01 and the standard deviation is 1.26. And let's look at the histogram. It is roughly round-shaped and roughly symmetric. Mound-shaped, approximately symmetrical, and normal. What is the standard deviation of the distribution? In this case, we found (1.26). But if you run this, since your samples are going to include different elements of the population, different people from the population, then your standard deviation might change. And your mean is going to be the same because the mean is the population sample. The mean of the sampling distribution is the mean of the population, but the standard deviation is going to change from sample to sample. Now take 500 random samples of size 100. Compute the average years of education from each sample, then create a histogram of these 500 sample means. How is the distribution different than based on random sample of size 10? Let's see. Iowa 500 is 500 samples of size 100. And let's look at the histogram. Compared to previous one. Let's look at the mean and standard deviation. Standard deviation changed. It became tighter. It became smaller. As we saw before, with the increasing sample size, the standard deviation, the variability of the sampling distribution is going to decrease. So in our previous example, our sample size was 10. In this example, it is 100. So it is expected that the standard deviation is going to be less than the previous example. So when I said the standard deviation is going to be different in the previous example, that's what I meant. It is going to be, for different sample sizes, standard deviation is going to be different. But the mean is going to approximate the population mean. As you see, it is very close, 7.01 versus 6.98. So both of them approximating the population mean. That's what we said, has a smaller standard deviation, hence has less variability. Compute the population mean and the population standard deviation for years of education. Next, calculate the standard error of the sample. Let's read the question, and then when we go to R, we are going to do this anyhow. How do the shapes of the sampling distributions differ and why? We are missing some tilde in here. Mean and standard deviation of education in the population. Let's look at this again, 6.97, and standard deviation is 3.98. And standard deviation of the sampling distribution for the sample size of 100, let's look at it. It is 0.398. We can create a distribution density function for normal distribution model. We provided mean 6.98 around here, and the standard deviation is 0.398 because that is what we calculated before, and this is the normal distribution model of the sampling distribution. If we look at standard deviation, if we calculate the standard deviation for the same variable education for sample size of 50, we get 0.56. Let's plot this together. The first plot is going to be the sampling distribution of samples of size 100. The second one, which is going to be in red, is going to be the sampling distribution, the model of the sampling distribution based on the sample size of 50. Let's compare. As you see, when our sample size decreased, the variability of the sampling distribution also, the variability of the sampling distribution increased. That's why we see the normal distribution model is going to be flatter from the previous one. We can compare in here too. For the sample size of 100, our standard deviation is 0.398. For size of 50 is 0.563. And for the first one, the variability is less than the second one. The sampling distributions differ because for a given population mean and population standard deviation, a larger sample size results in a sampling distribution with a smaller standard deviation. You know this by now very well. Create a plot of the standard normal distribution model. Next, create a plot of the normal distribution model with a mean of 2 and a standard deviation of 1.5. What is the difference between the standard normal distribution model and the normal distribution model? Let's look at it. Here's the plot of a standard normal distribution model. When we say standard normal distribution model, we immediately understand that the mean is 0 and standard deviation is 1. If we plot another normal distribution model, but this time it is not standard normal distribution, how do we know? Because mean is not 0, it is another value. In this case, it is 2, and standard deviation is not 1, it is 1.5. Let's plot this on the same scale. Let's go to our question. What is the difference between the standard normal distribution model and the normal distribution model? Standard normal distribution model does not change, but the normal distribution model shifts based on it is mean, and the variability changes based on the standard deviation is provided. Standard normal distribution model is a normal distribution model with a mean of 0 and a standard deviation of 1. You know this by heart right now. Suppose Daryl's age converted to a z-score is 150. You know the distribution of age is very closely approximated by a normal distribution. What is Daryl's percentile compared to other people in the population? We are looking at the probability distribution, and we know the distribution is approximated with a normal distribution model, and the z-score is 1.5. The z-score is 1.5. So the question, I believe, was asking the percentile. The proportion is 0.93. What does this mean? The proportion of the z-scores less than or equal to this z value, which is 1.5, is 0.93. The proportion of z-scores that is, which is greater than z-score 1.5 is the complement of this proportion, 1 minus 0.933, which is 0.067. But this is not in the question. I'm just giving you as an extra information. So, since we know the proportion, PDIST command gives you the proportion. When it's asked the percentile, we multiply this, and then our answer would be 93.32. Why it is 32? Because the next digit is 9. So we are expected to round our final answer to 2 decimal points. So that's why the answer, the percentile, 93.32. And let's continue with the next question. Now suppose Molly's age converted to a z-score, and it is -1. Is she older or younger than most people in the population? Let's look at her percentile or proportion. Since Molly's z-score is -1, she is at 15.86 percentile. 15.86 percentile. So, do you think is she older than or younger than most of the people? The rest are on 84.10 percentile, or the proportion of the z-scores or the other people older than Molly is going to be in this area. We can say that Molly is younger than most of the people in the population. Let's go and look at our answers. 93, what is Daryl's percentile compared to other people in the population? 93.32. She is at 93.32 percentile. That is what we calculated. Is Daryl older or younger than most people? Daryl is older than most other people in the population. This is Daryl. Now suppose Molly's age converted to a z-score and it is -1. Is she older or younger than most people in the population? As you remember, we found that Molly is younger than most of the people. Okay. You know that Keisha has 20 years of education. Suppose you also know that the average educational attainment in a population is mu 10, and the population standard deviation is sigma equals 5. The distribution of educational attainment is normally distributed in the population. What is Keisha's z-score? Can we calculate the z-score just with the information we know? We have the data, 20 years of education, and we know the mu, and we know the standard deviation. Based on this, we can easily calculate z-score. How? 20 minus 10, 10 divided by 5 is 2. How can we calculate this using R? Well, we have to calculate z-score manually. And then by providing the z-score, which is quantile also, to normal distribution model, we can see her percentile. Her percentile is 97.72. What is the probability that a randomly selected person from the population has an educational attainment equal to or less than Keisha? (0.98). Since the question is asking probability, some of you get tripped on this kind of questions, unfortunately. Since the question is asking what is the probability that a randomly selected person from the population, and we read the rest of it, probability cannot be bigger than 1. As you know, the probability is or proportion is bounded between 0 and 1. So our answer is going to be different than the percentile. PDIST command gives you the proportion. And by looking at this, 0.977, and we are going to round this to 2 decimal points. That is what we are expected to do. And the third digit is 7. So I need to increase the second decimal point by 1 because the third decimal point is greater than, is equal or greater than 5. From census data, you know the distribution of age in a population is normally distributed with mu 35 and sigma 10. Amy is 35 years old and Maya is 50 years old. What are the z-scores for Amy and Maya? We can calculate this by hand easily by now, right? 35 minus 35 divided by 10 is going to give us z-scores for Amy. 50 minus 35 divided by 10 is going to give us the z-score for Maya. So Amy's z-score is 0 and Maya's z-score is 1.5. What is the probability that a randomly selected person is older than Amy and younger than Maya approximately? Okay, let's go and calculate this with R. If we plot the probability distribution model by giving a range, (0 and 1.5, we will be able to see what proportion of the people falls between Amy's age and the Maya's age. Let's run it. So Amy's z-score, based on Amy's age, Amy's z-score was 0. What this means is the proportion of the people who are younger than Amy's age is 0.5. Maya's z-score was 1.5, which is in here, if you say 0.43, the proportion of the people who are younger than Maya, if you say 0.43, it would not be correct. 0.43 is just in between. So the proportion of people who are younger than Maya is this amount plus this amount, which is, R is already calculating this for you. It is 0.93. That is the proportion. So if we subtract the proportion of people who are younger than Amy, then the proportion of people who are younger than Maya, the interval is going to give us the people who are older than Amy and younger than Maya, which is 0.43. I forgot if the question is asking proportion or what is the probability? Okay, since it is asking, the question is asking the probability, the answer should be 0.43 0.43, because the third decimal point is 3. We don't have to increase the second decimal point. .43. From census data, you know the distribution of age in a population is normally distributed. You don't know Gabriel's age or z-score, but you know that the probability that a person is her age or younger is 0.90. Excuse me. What is Gabriel's z-score approximately? Well, in this case, we are going to use QDIST. We know the probability, but we would like to know the z-score. So in this case, we are going to use QDIST and provide the probability. It should be 1.28. This is our standard error. What this means is Gabriel's age is this Gabriel, right? Gabriel's age is 1.28 standard error away from the population mean. This is the standard normal distribution. That's why we are seeing zero in here. But if we look at the normal distribution model of this population, we would see the mean as mu in here. So we need to go and find out what was the mu. From census data, you know the distribution of age in population distribution is 35. So what we need to do in here is it 1.28, 0.90. What was the standard deviation? So this is what we need to know. Another thing. Let's look at this population distributed with 35 and 10. So then this is 1.28 standard deviation or standard error away from the population mean. 1.28 multiplied by 10. Why are we multiplying by 10? Because this is our standard deviation. We need to find the z-score. And Gabriel's age is 47.8. That should be our answer. And let's go and check. What is Gabriel's z-score? Approximately 1.28. That's what we found. And suppose the average age in the population is mu 35 and the standard deviation in the population is sigma 10. Using this information and the information from question 34, what is Gabriel's age approximately? That's what we calculated, 47.81. That should be your answer. Any question? So then this concludes our section today. Have a great day, everyone. See you soon.